Hey guys, so today we're going to be spending one more day on graphing sine and cosine functions, combining everything that we've learned to get on transformations and graphing sinusoidal functions for one more day. So I'm going to show you two examples. If after watching the first example you feel like you're good, feel free to stop the video and try to practice problems. And if you need another example, then watch the second example. So refresher. Standard form of a sinusoidal function is y equals a times sine or cosine of b times x plus h plus k. If all of the transformations apply, a is my amplitude or vertical stretch or compression, b is my horizontal stretch or compression or my frequency, and then hk are your horizontal and vertical shifts. So my recommendation is to start with moving the wave axis if necessary, because I know that my whole wave shifts up or down depending on what my vertical shift is. So in this case, in our example, we've got y equals 2 sine 3x plus 1. I know that my transformations are, I'm going to slide everything up 1, right? And so my whole wave slides up 1, and my wave axis is now at y equals 1 instead of the x-axis. And according to the equation, my amplitude is 2, meaning that my high point and my low point is going to be 2 units from my midline. So if you want, you could kind of draw in an upper bound and a lower bound. So you know that vertically, your wave has to fit within these boundaries, your middle, your upper, and lower bound for your high and low points. Next, we're going to identify the period and phase shift, and the frequency is going to help you identify the period. So frequency is b, which in this case is 3, meaning that we should be able to should be able to draw 3 full cycles of my sine wave in a 2 pi period. Okay, and then, the period that we're looking for is, what's the horizontal distance that it would take to fit 1 full cycle? So the period, remember the formula to calculate period is 2 pi over b. That would give us a period, in this case 2 pi over 3. So we can fit 3 full cycles in a horizontal distance of 2 pi, and we can fit 1 full cycle, its period, in a horizontal distance of 2/3 pi. Okay. So then from there, we don't have anything else, right? We don't have any phase shifts, horizontal phase shifts that we have to worry about, which is good. So because I'm not sliding left or right, I'm going to start at the exact same points on the wave axis. And then I know that I just need to be able to draw 1 full cycle from 0 to 2/3 pi. And if I can I know this is kind of hard to see where that would be, but if you just estimate 2 times pi, if pi is 3.14 divided by 3, 3.14 divided by 3 is really just basically 1, right, times 2. So this answer, 2/3 pi, is just basically a little bit past 2, like right here. Okay. And so let's draw my points on the wave axis first. And you need to know what the parent function of sine looks like. You need to know that, okay, I start on the wave axis and I hit a high point, come back down to the wave axis, hit a low point, and then come back down to the wave axis. So if you know generally what the shape looks like, then you can just go from there. So my first point is going to be at 0, 1. And then the next time that my point is at the exact same spot after 1 full cycle is going to be just past 2, so right here. And in between these 2 points, I know it's going to hit the wave axis again, so that's a little bit more than 1. Okay, and then between 0 and just a little bit more than 1 is going to be my high point going up to 3. And between a little more than 1 and a little more than 2 is going to be my low point. So that's going to be down at -1. And then I just draw my first full cycle. Okay, and I know that I should be able to draw 3 full cycles between 0 and 2 pi, so you can keep going if you want. So that's going to give me, here it is, and then here is my 1 full cycle. And then another full cycle, I'm just spacing it out. So between these 2 points, my point where it's going to hit the wave axis again, and then a high point and a low point. Here's another cycle. And then same thing over here, a high point and a low point. Here's another cycle. And if you want to go negative, you can do the same thing. Right here is a little bit more than 2, a little bit past 2 is going to be the exact same point. And then between that is going to hit the wave axis again. And then my low point and my high point, and here it is. So certainly you don't have to fill the whole graph, but I would draw at least 2 full cycles. Alright, here's another example if you need it. With cosine, we've got y equals negative cosine 2 times negative cosine 2 times x minus pi over 2. So from there, let's start with my amplitude. So my amplitude is 1. That is the number in front of sine or cosine. In this case, it's just negative. So the amplitude is 1, which doesn't change it. And then my frequency is 2. Right, here is my b. That's 2. That means I should be able to draw 2 full cycles in a horizontal distance of 2 pi. Well, if I can draw 2 full cycles in a horizontal distance of 2 pi period, well then 1 full cycle is going to take 1 pi, right? Let's see if that's true. So using the formula, period is 2 pi over b, in this case 2 pi over 2, which is 1 pi. Makes sense. If I can draw 2 full cycles of my wave in a period of 2 pi, then it's going to take 1 pi to draw 1 full cycle. Okay, let's identify any other translations and reflections. I've got a negative in front of the cosine, so I know that's a reflection over the x-axis. And x minus pi over 2, that's going to be a phase shift, right? Pi over 2 units to the right. So keep that in mind. All right, and I don't have any vertical shift, so that means my wave axis is going to stay where it is. And my high point and my low point is going to be up at 1 and down at -1, so that doesn't change. What I have to consider here is because I'm shifting, I have a phase shift, I'm sliding my whole function to the right pi over 2, so I'm not going to start at 0 anymore. I'm going to start at pi over 2, which is right here. Essentially, I'm just like shifting my x and y axis over. So that's going to be where I start, and I need to be able to fit 1 full cycle in a 1 pi period. Okay, so let's see where that would end. I know that my function is going to my parent function. Again, you should have an idea of what your parent function looks like for cosine. Normally it starts at a high point, right? And then it hits the wave axis, goes down to a low point, hits wave axis, goes back up to the high point. So that's what it looks like. Okay, and I need to be able to fit 1 full cycle of this in a 1 pi period. So that's going to end at, so pi over 2, if I add pi, so that's 2 pi over 2, that's going to end at 3 pi over 2, which is right here. Okay, so that's where I'm going to fit 1 full cycle. So let's start with the first point. I have, normally it's at 0, 1, right? Except now instead of at 0, I have pi over 2 up 1. Okay, however, I have a reflection over the x-axis. So I'm going to flip it over, and now I know it's down here. Okay, and then the next time that this point is at the exact same spot, it's going to be at 3 pi over 2. 3 pi over 2, -1. Okay, in between that, which is pi, it's going to be up at 1, because I have a reflection. And then in between those points are my points where it's going to hit the wave axis. And so here is my first cycle that I can draw. And I can do the same thing. If I want to draw 1 more cycle to the left of that, pi over 2, add pi to or subtract pi on the left the next time that this point is at the exact same spot is negative pi over 2. Right? And then between that, which is at 0, it's going to hit its high point. And then between the high and low point is going to hit the wave axis. And then again hitting the wave axis. And so here is another cycle. And that's it. So as you try to practice problems, please show all your work on how you calculate the period. The answer key only shows the graph and the answers for each of the characteristics, so make sure you do show your work.